For my project, I did Pascal's triangle. So I created an example of 5 rows of Pascal's triangle. So you start with 1 and then you move to 1, 1. And then you have 1 on either side, but to get the 2 in the middle, you add the previous rows 1 and 2. Then the next row you go to 1, 1, and then you add the 1 and the 2 to get the 3, and the 2 and the 1 to get to the other 3. And you keep going down by adding the previous boxes above it that it's connected to. So for example, 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. And either side has a 1. So some interesting facts about the Pascal's triangle. The first diagonal is all 1s. The second one diagonal is all counting numbers, so 1, 2, 3, 4. The triangle is symmetrical. The horizontal sums double with the rows, and I'll show you that in a minute. And each line is an exponent of 11, and I will show you that in a minute also. So the horizontal sums. So the first one is 1, and then you have 1 plus 1, and it's just 2. So how do you get from 1 to 2? You multiply by 2. 1 plus 2 plus 1 is 4. 2 times 2 is 4. 1 plus 3 plus 3 plus 1 is 8. 4 times 2 is 8. So you multiply by 2 all the way down. Then the second one, the row was 1, which is 11 to the 0 power. Next row was 1, 1, which is 11 to the 1 power. Then the third row was 121, which is 11 cubed, excuse me, 11 squared. Then 1331, which gives you, or 1331, which is 11 cubed. Some history about the Pascal's triangle. The pattern of the numbers were developed before Pascal's time. In Iran, it is called the Kaham triangle. In China, it's called the Ying-Han's triangle. And the triangle was named after Pascal by Pierre Raymond de Moivre. So some modern day uses is binomial expansion. So parentheses x plus y squared becomes x squared plus 2x plus y plus 2. And your coefficients are 1, 2, 1, which is the first row of the triangle. Another one is the combinations. So instead of performing the calculations, you can actually look in the rows. So an example was if you eat 3 desserts from a cart of 5, how many ways to do that? And you look in the You look in the third entry in the 5th row, so that would be 10 right there. I've circled that. And then down there, I performed the calculations to prove that it was 10.